طيب كلها demonstration. Anyway, no matter. Okay. So again, guys, to sum up everything, if we have two particles that are attached by each other by a taut string, okay, now, and those particles will have each same acceleration, initial speed, final speed, displacement, and what? Tension. Okay. The string should be light, inextensible, and what? Taut. Okay, light, extensible, and.
ايش قصدك بتوت؟
يعني مشدود.
Okay, fine. Right. Then we will use the terminology of what? Of Newton's second law. F net equals ma along horizontal, vertical, along the perpendicular direction of directions. Okay? Right. Let's go now to exercise. To apply this, let's go to exercise 3F. Exercise what? 3F.
Page 64.
Page
64.
64. Let's start, I think, with the question 1. Question 1. Question 1. Okay. Again, what do we have in this question? Look. Two particles, P and Q, of mass 8 kilograms, 2 kilograms, are connected by light inextensible what? String. The particles are on a smooth horizontal plane. The particles are on smooth horizontal what? Plane. Okay? Okay, horizontal force. Okay. A horizontal force of magnitude P is applied, of magnitude F, is applied where? To P. Okay? Well, no matter the direction of motion, and if it's in this way or in this way, it's not mentioned. You can take either ways. Okay? Fine? But P, now, there is a force F applied where? On P, in direction away from Q. When the string is taut, the particle moves with the acceleration 0.4. The acceleration of the system is 0.4 meters per second. Okay, guys? What we are asked to find? F. Okay. Look here, please. Now I will treat these two particles separately. Okay? I will treat them what? Separately. What do we have here? What are the forces here? Weight.
No.
Which is 8G, sorry. 8, correct?
8.
Normal force. And here what?
Irresistible.
Tension. Right? And the string, along the string, there is what? Tension. The tension would be in this way. Okay? Similar tension is applied along Q, but in the opposite direction. Similar tension, because the string is taut. Because the string is taut. Because every action has equal and opposite reaction. Always the tensions will be in the opposite direction. Okay? Fine? What we will have also here?
Weight.
4G or 2G?
2G.
2G. Normal. It's a smooth. Pay attention, please, guys. It's a smooth, so no friction. So these are the forces that are applied where along the two particles. I will treat them individually. طلع شو حكي هلا? For Q, for what? P. For Q, where is the motion? F net forward equals what?
0.
MA. This is there's an acceleration. Pay attention, please pay attention. F net equals what? MA. Pay attention here. Guys, always the tensions along the objects will be in the opposite direction. Always. Okay, fine?
Wait, what?
Always the tension along the objects will be in the opposite direction. Okay, what do we have along Q only?
Tension.
Tension. In this direction we have only what? Tension. So T equals mass
2G.
2 times the acceleration what? 0.2. So tension equals 0.8 newtons. This is what? Tension. For P, F net along this direction also equals what? MA. Clear? because the motion actually were in this direction. The motion in this direction. What do we have along P?
F
F
minus T.
minus T equals MA. We have T now, right? Which is 0.8. If the string is taut, both will have the same tension. So F minus 0.8 equals 8 times
0.4.
fine?
الأستاذ عندي سؤال.
Yes.
هلا صح those P and Q they're connected by string.
Yes.
And if there's a force applied on P, it's going to affect Q.
It will affect Q, but not directly.
بس يعني why?
Through the tension, actually.
Through the tension.
Yeah,
If
through the
is
tension.
applied,
Let's say, the tension intermediate, the force between P and Q.
خلاص okay.
Okay, fine.
يعني ما عم نحسبها اليوم.
Yes, excellent. It's a good question, girls. Pay attention, please. F is applied only on P, so it affects what? P. But it affects Q indirectly, but we will not consider it in the Newton's second law. Newton's second law only, we will consider the forces that act what? Directly on the object. Clear? So F equals 4 in Newtons. Fine? This is A, yeah.
How come like you found T then you found F?
No matter.
But they asked for F first.
Yes. If you start from P, you have to find what? T. So always you have to go to the other side of the or the other particle, okay, and record what or find the value of T.
Can't you assume in the QP they're one particle تاخد الماss تاعهم both?
Definitely you can. Yes, but actually listen. This is the formula. I'm trying to formulate something because in the past paper or in the external exam, you are commonly asked or mostly asked about tension and acceleration. Tension and acceleration. So you have to find two equations with two variables. One from Q and one from where?
طب أستاذ بدل أنا عكست.
No matter. عكست what?
إنه بدل P إنه P و Q عكستهم.
بس الفورسز انا ما بيهمنيش البي والكيو.
طبعا بحط الفورس هيك ولا بحطها هيك؟
If P is here, the force will be there this way. Same thing, same thing. Okay, what we are asked later be
Tension.
That's it, you found it.
tension. It's found. Okay. Tension what? It's 0.8 newtons. Okay, it's found. Okay, tension 0.8. Similar terminology of the previous case, except both particles will have the same acceleration and same tension, and we have to know how to write what? The tension force in appropriate direction, okay?
Done.
Yes.
Yes.
Yes. Yellow. 3F question 2.
Two
Yes.
birds, two bricks, P and Q, each of 5 kilograms, are connected by a line inextricable string.
Yes.
Brick P is held at rest and Q hangs freely, vertically below P.
Listen to this. And then two bricks, right? A, B. It's mentioned in the question that B hangs freely where?
DQ.
PQ, sorry. PQ. Q is hangs freely-ish, below-ish, P, صح? By what?
Inextensible.
Light and extensible string, right? Complete, please.
A force of 200 Newton is then applied vertically upwards to P.
Look, 200 newtons is applied when? On P, right? Is applied where? On P, yes.
Causing it to accelerate 1.2 meters per second square.
1.2 meters per second square. Accelerate where? Upward, right? Causing to accelerate the system of two particles upward. Complete?
Assuming there is a resistance to the motion of each of the bricks of magnitude Rn, R newtons,
Yes.
find the value of R.
Okay, here R, be careful. R we regularly use at,
As normal.
yes, R regularly used as a normal, okay? But here in the question is defined as resistance. No matter, okay, guys? Here in the question, it's defined as resistance. So what do we have here? We have resistance also, right?
And
Be careful. R is what?
resistance.
Resistance. What other forces here?
So wait, is R weight or?
R resistive force. It's called resistive
Yeah, is it friction?
friction. Yes, frictional force.
Do you
Yes,
weight?
definitely. Where is the weight?
Downwards.
The weight of P is 4G. 5. The weight for Q,
5.
similar,
Yes.
5G. What else? Be careful here, guys. Be careful. Here there is a tension downward applied where on P, or opposite with the same magnitude tension is upward applied where on Q. Clear? Any question? Is there any other forces? Is there any other forces?
No.
Sure? Okay, right. What we have to do, as usual, for P, for what? Q. Pay attention. What is the direction of motion? Upward. F net, upward equals what? MA. F net similarly upward equals what? MA. Both of them are moving where? Upward. Clear? Any question? Now, what do we have here on P? 200 minus friction minus tension minus what? 5G equals what? 5A. Okay?
1.2.
Clear? 5 times is 1.2. Yes. Any question about this? Yes.
The normal for the Q.
It's not a normal.
The Q.
There's no normal. Guys, pay attention, pay attention. Pay attention, please. It's not, these particles are not do not lie on a surface, right? Or they don't move along the surface. Clear? What is R? R regularly and we get used it as normal. But here it's defined as a resistance force. So it's a friction. It's defined in the question of friction, okay? So I have to use it as it is. It's not a normal. Be careful. It's not what? A normal. Yes, ma'am.
Stas, what if it wasn't a string, like it was like a wire?
Slack.
A wire.
Wire, string, rope.
Is it solid? You could feel normal force. It's a rod.
If it rests on it, and if the particle rests on wire or rod or
It
whatever.
rests on a string. It doesn't-
Yeah. Is there a question about the forces here? Okay. Actually, in the question, what we are asked to find?
R.
Normal and, tension and R. Tension and R. Look here, please. For P, how many variables here? 2. R and T, right? R and
The thing is,
2.
it does.
Yes. We need to have another equation. Okay. F net upward equals MA. This is for which particle?
Q.
For Q. Okay? For what? For Q. So, what do we have for Q? Look here. T for Q. Look. T minus what? Minus R minus 5G equals what? 5 times 1.2. Look to these equations. I can solve them simultaneously. 200 minus 49,
151.
151 minus R minus T equals 6, right? Here, T minus R minus 49 equals 6. This is equation number 1. This is equation number 2. Clear? So what I have to do later, simultaneously. Look how (151) minus R minus T equals 6. T minus R minus 49 equals 6, right? If I add them, if I add them, just add them, what we will get?
تي وتي بتروح مع بعض.
Excellent. T cancels T. Just add them.
Minus 2R.
Okay. 151 minus 49.
102.
102, right? Minus 2R equals what? 12. Clear? Any question? So R equals
تطلع 45.
now we got what?
R.
R. We can substitute in any of these what? Equations. I will find T.
تطلع 100.
Substitute here or here, whatever. Here, T minus 45, right? Minus 49 equals 6.
100.
So T equals what? 100 newtons. Is there any difference? Is there a major difference? Any major difference between this system of two particles and system of one particle?
No.
Okay, fine.
Yes. Break them.
Actually, now we have to distinguish between what? If the two objects are connected by a tow bar or by what? String. Tow bar rod, which is rigid, right? Not like what? The string. Not like the string. Hello, the string, during the deceleration, the string becomes slack. During the deceleration, the string becomes what? Slack, because it's not rigid. It's not what? Rigid. Share slack. What is meant by slack? Yes, exactly. But the tow bar, pay attention. The tow bar cannot be slack. Cannot be a slack. Why? It's rigid, right? It's what? Rigid. Look here, please. If two particles are connected by a string, similar thing, during the acceleration, look, during the acceleration in this direction, this is the acceleration. This is the tension, and this is what? Tension. Always opposite direction. Okay, always in the opposite direction. In the tow bar, similar thing. If there is an acceleration in this direction, okay, here there is a tension, here there is what? Tension. Similar, yes. Where is the difference during the deceleration? Pay attention, please. During the deceleration, here the string becomes what? Slack. Here, slack, string. Slack what? String. So the tension is what? 0. The tension is 0.
Acceleration cut over, there's no difference, right?
No difference, yes, no difference. In the acceleration, both tow bar and string, right, will behave in the same way, especially the tension. Pay attention now for deceleration, please. For deceleration. Look here, please. For deceleration, the string becomes slack, but the tow bar cannot be slack, right? But what will happen here? Pay attention. Look here, please. If there is a deceleration in this way, here instead of tension, we will have thrust. Instead of tension, we will have what? Thrust. Thrust in this way.
Why?
The thrust in this way. Okay. Why? Pay attention, please. Guys, look here, please. Look here, please. If there are two particles like this attached by tow bar, two cars, or car and trailer, pay attention here. Look here, please. Always the braking system will be where? On the car, not on the trailer. Right? So when the car decelerates, the trailer will continue in its motion where? Forward, right? When the car decelerates, the trailer continue in its motion where? Forward. So what will do? The trailer will push what? The car where? Forward, which is what? Thrust. As well, the car will push the trailer where? Backward by a thrust force. Similar in magnitude but opposite in direction. But if the two cars or two particles are connected by slack or string, sorry, which is slack, the tension becomes zero. Okay, the tension becomes zero. Is that point understood?
Yes.
Clear?
Yes. ايش فرق الثرست عن التنشن؟
In the opposite direction.
Oh.
يعني, in other words, girls, in other words, حتى even that, in other words, if there's a deceleration in the tow bar, the direction or the force now in the tow bar is what? Thrust. And it will be in the opposite direction of what? Of tensions. Okay, fine? Any question about this? Okay, look to question 3.
بس عادي نرجع شوي.
Let me do question 3, but we'll give you time. Copy everything. What do we have in question 3? Car and trailer, right?
Car of mass
Yes.
1,500 kilograms. So, ow.
Of mass, doing what? Trailer of mass 500, okay?
لا 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 ما يا ريت
بس هو ده
Okay, guys, this is 500, 1,500 kilogram, towing trailer of 500. The car and trailer are connected by light extensible tow bar. The engine of the car exerts a driving force magnitude 10,000 newtons, right? This is the thrust of the engine. 10,000 what? Newtons. 10,000 newtons forward, okay? The car and trailer experience resistive force 3,000, 1,000 respectively, right? 3,000 and 1,000 respectively. We are given the resistive force here, or the frictional force, okay? So, what do we have here? Normal upward, right? 1,500 G weight. Because it's accelerating, so here we have what? Tension.
Also resistance.
Right? And also we have resistance 3,000. Here, resistance what? 3,000 newtons. Okay? Fine?
ليه بهذا الاتجاه؟ ليه مو بالعكس؟
Opposite direction.
هاي تنشن مش ترست.
Right? Opposite what? Direction.
لا قصدي resistance.
Hold motion in this way.
اه اوكي.
This is the direction of what? Of acceleration. Look, what do we have here? Force from the engine, normal, weight, resistive force, 3,000, and what? Tension. Why tension? Because it's accelerating. It's what? Accelerating.
F net.
The other side, or the other particle, which is the trailer, tension in this way, friction in this way, which is what? 1,000 newtons, right? Normal, and weight, 500 G. 1,000, right? Resistance force. Clear? Okay. Tension, normal, weight, resistive force. What we are asked to find? Tension and acceleration. Tension and acceleration. What I have to do for the car, similar to what we did previously, F net forward equals MA. What we have forward forces, 10,000 minus tension minus what? 3,000 equals what? 1,500 A. Look, if we are considering the horizontal force, should we consider the vertical forces? No, because they are independent. Okay? Look, in this question, or in the previous questions, if we deal with horizontal force or horizontal forces, the vertical forces will not affect the horizontal forces. As well, the horizontal forces will not affect what? The vertical forces. Clear? What we have unknown here? Tension and acceleration. 10,000 minus 3,000. 7,000 minus tension equals 1,508. This is the first equation. Now for what? For trailer. F net forward equals what? MA. What do we have forward here? Look, we are treating them independently, individually, sorry. Sorry? Yes, this is alone. Tension, yes. minus 1000 equals 508. This is equation number 2.
Start الأكمل for both of them should be in the same direction.
Yeah, definitely, because they are moving in the same direction. System of two particles, the resultant force of them should be in the same direction. If the string is taut. If the string is taut. Now, yes, just a minute. 7,000 minus t equals 1,500a. T minus 1,000 equals 500a. Yes, actually these type of questions, or algebra, these type of questions is easy because actually always we will get two different directions for t, so eventually they will cancel each other.
Okay.
T cancels t, right? So 7,000 minus 6,000 equals 2,000a divided by 2,000 divided by 2,000. A equals what? 3 meters per second. If we got A, substitute in any of these equations, so you will get T. And actually, as what I mentioned before, always we will have the first two parts of this question in the past paper or in the external will be in the same way. Tension, acceleration. Two equations should be done simultaneously. These two parts will have around 8 marks.
Wow.
8 marks, right? So you should master this point because it should be done easily and straightforwardly or fast, okay? Trying to consume your time. Had additional time.
2,500.
2,000
What? 2,000.
units, yes, Amir. Any question about this?
No.
You look up this.
So 0 with 36.
Sorry?
With 0 with 36.
4.
Question 4. Now, question 4, two particles A and B. Look, A and B, two particles. Okay, here. Look, two particles A and B. They have two different masses. One is 4 kilogram, the other is 3. Respectively, are connected by light and extensible string, which passes over a small, smooth, fixed pulley. The particles are released from rest. Find the tension where in the string. Look here, please. What do we have here? Two particles are attached what? To by string in the pulley. Okay. Now they have what? The same, or they are at the same level. Okay. Please look to this demonstration. Okay, girls, here. Look to this demonstration. It's very important. Look exactly. We have to observe what will happen to particle B when A reaches the ground. Okay. Particle what? B. This is B. When A what? Reaches the ground. Look. I will release it now. 1, 2, 3. What will happen? Yes. Actually, what will happen here? When particle A reaches the ground, right? Particle B does not stop immediately, but it will rise to maximum height and returns back again. Right? Stop for a moment and returns or falls back again until the string becomes what? Taut again. And the string becomes taut. Clear? When A reaches the ground, listen, when A reaches the ground, at this moment, the string becomes slack. Right? At this moment, the string becomes what? Slack. So the particle B will complete in its motion upward until it reaches a maximum height. Right? Then it falls back until the string becomes what? Taut again. Clear?
When the height becomes
when A reaches the ground, say tension 0. Right? Pay attention, please. Question 5, right? 4. 3F. Question 1, 4. The first part, as usual. This is what? The pulley. Okay? We have two particles A and B. A. Here another particle what? B. A downward force, which is 4G. Tension towards always what? The pulley. The tension is always towards what? The pulley. Look to B. B 3G downward, right? And also the tension will be what? Towards the pulley. Okay, fine? Where is the direction of motion?
Towards the pulley.
Where is the direction of motion? Look. Yes, excellent. We observe this, right? This is the motion.
بس أستاذ المفروض B تكون هي الأتقل.
B أتقل؟ A أتقل.
اللي راح ينزل تحت هو اللي أتقل.
Yeah. Yes.
Okay.
The motion this way. صح? The motion for A will be where? Downward. Accelerated downward. Will be accelerated where? Upward. By the same acceleration. By the same acceleration. What I have to do, similar what we did before. For A, F net where? For A, F net is where? Sorry. F net is where? Downward, right? The resultant force where? Downward. Okay?
No.
So, what do we have here? Look here. 4G minus what? Tension equals what? 4A. This is equation number 1. 4G downward minus tension because it's in the opposite direction of motion equals what? Mass times A. Now for B, yes, excellent. For B, F net upward is equals what? MA. F net upward is
T minus
yes. T upward minus what? 3G equals what? 3 times A. 3 times A. Girls, pay attention here, please. It's an important point that we have to notice. Look here. Are the tensions in the opposite direction?
Yes. No.
They are.
They are. Look.
What?
4G minus T. Here, T minus 3G. In the figure here or in the free body diagram, they are appeared in the edge upward, but actually they are opposite. One of them with the direction of motion, with the other in the opposite direction of motion. Okay? Fine? So, now this is the second equation. Now by doing the algebra, simultaneously 2 equations, it's easy now. 4G minus T equals 4A, T minus 3G equals what? 3A. Tensions will cancel out each other, right?
A equals 1.4
4 minus 3G, 7A. So A equals what? 1 over 7G meters per second. Or you may find it as what?
1.4.
1.4. Okay. A equals 1.4 meters per second. Yes. Actually here we are not asked to find the acceleration, but I can't find the acceleration unless I found I can't find the tension, sorry. I can't find the tension unless I found what? The acceleration. Then substitute the acceleration in of these 2 equations. We will have what? The tension. T minus 3G equals what? 3, 1 over 7A, G. Clear? Look, instead of A, I substituted here, substituted here 1 over 7. Plus 3G, plus what? 3G.
33.6.
Yes, T equals 3 over 7 plus 3.
33.6.
33.6. 33.
29.5.
I know. 24 over 7G. I may write it as like this, no matter. Okay? Or I may write it as
33.6.
33.6. Clear?
Yeah.
Okay. Look here, please, guys. This is the ground, right? This is what? The ground.
Yes, why do?
And what we are asking the question here for? as A falls 2 meters down, يعني A reaches here, right?
هذيك راح تطلع 2 meters up.
Definitely. If this falls 2 meters, let's say this is the initial position. We redraw this. A was here, okay? A was here. Then A descends what? 2 meters what? Down. Okay? When A reaches the ground, what will happen to this string?
Slack.
Slack. Pay attention, please. Girls, pay attention. So, initially, wait. This is what? B. This is A. This is the position of
The original.
the original position or the initial position of B, and this is the original position of what? Of A. Now, if this falls or descends 2 meters, this will rise what? 2 meters. After this, what will happen? What do we observe in the demonstration? Yes, this particle will continue in its motion where? Upward until it becomes at instantaneous rest, okay? Until this is the maximum what? Maximum what?
Height.
Height. At maximum height, the velocity is
0.
0. At maximum height, the velocity is 0. Again, look here. A was here and B was here, okay? A descends downward 2 meters. So B will rise up 2 meters. After this point, the strength becomes what? Slack. While B will not stop immediately, it will continue moving upward for a certain distance until it becomes at instantaneous rest, then it will fall down again. Yes? Yes. Yes?
Does any weight when it becomes slack, the weight pulls it to be tall?
Yes. Actually, but here we have, it will decelerate after this. It will what? Decelerate.
هذا الفاينل بوزيشن تاع بي.
هذا الفاينل position. Actually here, انتبهوا معي شوي هلا I will explain this for you. Here we will have 2 stages of motion. Stage 1, this is what? Stage 2. Why? Who can tell me why I divided the motion in 2
Acceleration is
stages?
not equal.
Yes.
Wait, اللي بعدها بعد يكون tall.
Yes, why? That's why I divided this motion.
Acceleration مش
معقولش
نفسه.
طلع منه استاذ تطلع ما قدرش ترجع تنزل.
لا لا مش
acceleration and deceleration.
Yes, well, actually, like what Sarah say, actually here, pay attention here, here. Sit properly, please. Actually, after this position, there is no tension. There is no tension. So the resultant force will change as well. What? The acceleration. If we have 2 different accelerations, so we have to divide the motion in 2 stages, right? With constant, each stage has constant what? Acceleration. We are asked to find the maximum height. We are asked to find what? The maximum height. So now all our treatment for particle what? For B. Okay, for particle B. When A reaches the ground, the strength becomes what?
Slacking.
Becomes slack, but B will not stop immediately. It will decelerate upward until it reaches what? The maximum height, okay? Until it reaches what? The maximum height, okay? So here we have stage 1. Pay attention, please. Look to stage 1. Stage 1, always draw a free body diagram for stage 1. Stage 1 we have all this treatment for what? For B. In stage 1, what do we have? We have tension upward, right? 3G where? downward, المومنت acceleration were upward. This is what stage
2 meters.
1, yes. Stage 2, look to please. Stage 2. Stage 2 now there is no tension. Only what?
Wait.
3G. The motion still were upward. But now the acceleration here is different than the acceleration here. The tension in stage 2 is what? 0. Clear? Pay attention, it's an important point. Okay? You hear, there's a tension, stage 1 here, there is no tension. Because the tension here is 0, so the acceleration will change. What we will have here also, information given, U0, displacement is what? 2 meters. Acceleration was found 1.4 meters per second square, right? What we have in stage 2, V0, we need S, right?
And acceleration.
This is the only thing. So what I have to find?
Acceleration.
Acceleration, right? I have to find what? Acceleration. Again, F net still upward equals what? MA. Pay attention, please. Pay attention. Pay attention, please. F net still upward. Particle should be continues in its motion when upward. What do we have? Minus 3G. Why minus? Because the 3G against what? The motion equals what? 3A. So A equals minus 9.8 meters per second. Yes, it's acceleration of free fall. Definitely, because the only force acting it is what? The weight. What do we need also? Look, I have acceleration, I have velocity, guys, I have acceleration, I got the acceleration now, I have final velocity, we need displacement, I need either t or initial speed. Listen to what did they say again.
Initial speed.
No, stage 2 has stage completely different than the previous stage, right? Pay attention please. Here, I have acceleration, final velocity. I need displacement. I need another variable, either time or what? Initial speed for stage 2. Initial speed for stage 2. Time I can't find it, but listen, the final speed of stage 1 is the initial speed where? Stage 2, right? Final speed in stage 1 is the initial speed where? Stage 2. So what I have to do here, I have to find final speed in stage 1, which will be the initial speed where? Stage 2. Clear?
V squared.
So V squared, excellent. U squared, 2AS. These guys, you have to divide the motion to two individual or two separate stages. V squared equals U squared 0, 2 in A 1.4 with S 2. V equals
2.4.
2.4 meters per second. So here, the final speed in stage 1 equivalent to the initial
الدلتا بتاعت minus
speed
2.4.
in stage 2. يعني U here equals what?
V.
2.4. Now I have U, right? Just a moment, please. I have U, V, S and A. What can I find? S. V squared equals U squared plus 2AS. V squared 0, U squared 2.4 squared plus 2A minus 9.8 times what? S. Clear? So S equals
14.
14.
مستحيل صح؟
0 point something.
كده
بتاخدي سكوير 0.
لا ما تاخذ سكوير روت.
كم؟
لا
0.29 meters.
صح؟
Guys,
0.29.
yes, addition the maximum height. Listen. Just one moment. One moment, please.
2.29.
Yeah, this
Yes,
is
you have. This is the maximum, right? Height from the initial position. This is the maximum height. 2 here, the height here is what? 0.29 meters, right? So the maximum height.
2.29.
That's sufficient picture. If I do this.
Okay, fine.
Are you doing this? Yeah.